Next problem to find the sample size, that is the single mean test, right? The management of manufacturing firm wishes to determine the average time required to complete a certain manual operation. There should be 0.95 confidence that the error in the estimate will not exceed 2 minutes. What sample size is required if the standard deviation of the time needed to complete the manual operation is estimated by a time and motion study expert as first one 10 minutes, second one 16 minutes. So here they have taken a manufacturing firm, so some manual operation. So in that manufacturing unit, they are doing some manual job, right? So the confidence error of estimate will not exceed 2 minutes is 0.95, that is also given. So they are asking what is the sample size is required. The standard deviation of the time needed to complete the deviation in completing the job, manual job. First 10 minutes, second question 16 minutes, right? So solution, given population standard deviation sigma is equal to 10 minutes, that is what they have. What is the sample size required if the standard deviation of time needed to complete, right? Deviation in the time, that is what they have given. First question, sigma is equal to 10. Error they have given 2 minutes, right? To find the sample size n, so there should be 0.95 confidence, right? Note that 0.95% confidence limit. So we are taking z alpha value according to that. So substituting the values in the formula. So we know that n is equal to z alpha square sigma square by e square. So 95%, that is 0.95 value of z alpha, that is z alpha both are same, so it is equal to 1.96. Alpha indicate the confidence level, right? Here 95% confidence level. So n is equal to 1.96 square, sigma we know 10 square, and error equal to 2 square, that is equal to 96.04. Hence the approximate sample size is 96, right? Second one, given population standard deviation. Next question, so sigma is 16, error is 2, same sample size n is equal to z alpha square sigma square by e square. Substituting the value 1.9 square into 16 square by 2 square, that is equal to 245, approximately 246. So sample size n is equal to 246. Next question, a research work wants to determine the average time it takes a machine to rotate the tire of a car, and she wants to be able to assert with 95% confidence interval that the mean of her sample is off by at most 0.50 minute. If she can presume from the past experience that sigma is equal to 1.6 minutes, how large a sample will she have to take? Actually, you know, in the wheel alignment units in the mechanic shed, so rotate the tires of the car, right? They will check that, right? Determine the average time it takes a machine to rotate, that is the machine, to check the wheel alignment machine, take it as it is, right? Tires of a car. So 95% confidence interval, mean of a sample is off by at most 0.5 minutes, right? So we'll see population standard deviation sigma is equal to 1.6, right? Error is equal to off, sample is off, mean of her sample is off by at most 0.50, that means that is the error difference, right? E is equal to 0.5. To find the sample size n is equal to z alpha square sigma square by e square. So 95% here, same value, z is equal to 1.96. Substituting the value n is equal to 1.96 square into 1.6 square by 0.5 square, that is equal to 39.338. So sample size n is equal to 39. Next problem. The mean value of a random sample of 60 items was found to be 145, right, with the standard deviation of 40. Find 95% confidence limit for the population mean. What size the sample is required to estimate the population mean with 5 of its actual value with 95% or more confidence using simple mean, right? So here given sample size n is equal to 60. First line, we are taking the first line. The mean value of a random sample of 60 items, n is equal to 60. Mean sample, so sample mean x bar is equal to 145, and its standard deviation small s is equal to 40. That is what first line. Next line, to find 95% confidence interval for population mean, right? So that is what they find the 95% confidence limit for population mean. That is for the first question, right? So the required confidence interval is, we are writing the formula x bar plus or minus z alpha into s by root n. So substituting the values 145 plus or minus 1.96 40 by root 60. So 145 plus or minus 1.96 into 5.164. So we are getting 145 plus or minus 10.121. So there are two values. First you take 145 minus 10.121, that is the lower limit. Then second value 145 plus 10.121, that is the upper limit. So 145 minus 10.121, that is equal to 134.879. Then 145 plus 10.121, that is 155.121, that is the upper limit, that is the confidence limit, right? Next, to find the sample size when error is equal to 5. So we know n is equal to z alpha square is square, because instead of sigma they have given s, so that is why we are using s, right? S square by e square. So 95 confidence limit, same value, z is equal to 1.96. Therefore n is equal to 1.96 square into 40 square by 5 square. So that is equal to 245.8624, approximately 246. So sample size is 246. Thanks.